In theory, I'm live. Hey everyone, welcome to the May the 4th. May the 4th be with you. Episode of Open Space here on Fraser Cain's YouTube channel. This is like the first just me question show that we've been doing in probably, 6 weeks or so. And part of the problem is just there's been so many amazing guests, and we're probably going to go back to having a whole bunch of amazing guests. Like next week we've got Moya McTeer, and I've got a bunch of other people that I want to queue up as guests. So again, I'm kind of torn. So, all right. So first, I got to address a couple of issues here, obviously, which is like, what happened to all your content, Fraser? It's been mostly quiet. I mean, there's been a bunch of live stuff, but where's the scripted shows and where are the question shows? And there's a bunch of reasons for that, right? And so, like, obviously, the elephant in the room, the thing is obviously the pandemic that shall not be named, which unless we get demonetized. And that is, that has just been tromping around through all of our work. My focus, my job is the publisher of Universe Today. And so my focus has been to batten down the hatches, to make sure that I'm able to keep everybody hired and try to employ as many people as I can during this period. And so sort of running through all of the administration and just keeping that process going has been consuming the vast majority. And the second thing is, I'm hanging out with my kids. Well, one kid is actually now, she's like house sitting for someone, and she's like, and they're trapped outside of Canada, and so now it's like it's her house now. It's and dog. It's the weirdest thing. But my son is back here with me, and so we're spending a lot of time together, mostly, helping to coordinate his activities and try to keep him focused. So that's been a big situation as well. And the big one, I think, is just like it has fricasseed my brain. Like there's no way to describe this. The anxiety, the grief, the focusing on just the number of people who are dying and suffering around the world and what's yet to come is very hard on me wanting to sit down and write for long periods of time. And so that has been surprisingly difficult to deal with. And so I've been able to sort of, as long as I've been able to focus on, let's make sure that I can keep all of the team fed. Let's make sure that I can keep my son educated and healthy and happy. That's been my focus, and it is hard. And I think we're all going through this, and we're all suffering the extent of this. I mean, for the people who are like, for me, I'm so fortunate that I was already running a virtual company, and so, our revenue has dropped in half, right? And so that's been tough, but it's like, at least it's merely half and not all, which I know a lot of people are stuck at home. They're not sure where their next paycheck is going to come from. They're not going to be sure if they're going to be able to pay their rent, pay their mortgages. It's really hard out there. And I am so sorry for those of you who have already suffered so much, and we're gonna be suffering more, and this sucks, and we're all in it together. And so that is the part that, when I think about the things that do get me up and do make me move forward and make me want to contribute, I know that during this time, it is the entertainers like us who can bring you some joy and happiness, and if at least, as we all put on our 15 pounds in the house while we wait for the quarantines to lift, at least we can come out knowing a lot more and having a much better education. And so I think that is the part. And I feel much better now. I think now I don't check the news very often anymore, and I feel a lot more productive and a lot more encouraged about what we're doing. So that's where we're at. Again, I apologize, and I know a lot of you are going through a lot of difficult times. So, but we must continue with the space. So let's get into it. All right, Aaron's asks, what is your thought on the Navy release of the video of the UFO? Do you believe it's aliens or experimental aircraft? That's a great question, and obviously everyone wants to know what I think about the Navy release of the aliens. There are some great, really comprehensive debunking videos now that have been produced. I haven't seen there's like 3 of them now. The one that I think is just the best is the Go Fast one, where, because the Go Fast video, if you haven't seen it, like it looks like this like white object is moving really quickly, zipping across the ocean at just flying above the waves at some ridiculous speed. But everything you need to know about that object is baked into the camera itself. It tells you the angle that the camera is facing, the direction that the aircraft is flying when it sees it. You see the speed that everything is going, the distance to the object from the aircraft, and you know right away that in fact it's not flying very short. It's actually flying at a very high altitude, and when you do all the math, the object is only moving very slowly. And the object is very cold, and the object is very small, and it works out perfectly that it's a balloon. Like there's no question that that thing is a balloon. So each one of these objects have been beautifully debunked. And even if they weren't debunked, right? Even if you're like, okay, yeah, there is no question, whatever that thing is, it is moving incredibly quickly and we don't know what it is. That merely puts it into the category of UFO, unexplained, unidentified, flying object. When you say that you don't know what something is, you then can't say, but I know that it's aliens. So, I highly recommend. I will put some links in the show notes, and in fact, I'm going to be reaching out and doing an interview with one of the best debunkers of this. So stay tuned on that. I hope, and we can talk about it more in depth and just go into the details. But I think so far, those 3 videos are not convincing that they are aliens. Right? Aliens means the spacecraft lands and you get a chance to study it and you examine the material and you look at what the metals are made out of. And so far, every piece of evidence that has ever been put forward does not show that it is aliens. So, and Neil, you was asking on top of that, right, why no hot exhaust and infrared on the UFO moving into 120 knot wind? So as I said, right, if you do the math, if you triangulate the speed, the position, it's a cold balloon. It's not hot because there's no engine. It's not moving very quickly. It's just moving with the wind. So I think that it's interesting to sort of see this go back and forth. And I think that it's just really important that we all always say, don't leap to conclusions, right? What is the answer? The answer is, I don't know. It is unidentified. And as I've said before, you cannot unidentify yourself to knowledge. They are in the opposite directions. So, all right, let's get on to some other questions. Jiro the Hero, if an advanced civilization wanted to hide its techno signatures, how do you think that they would do it? Okay, so this idea of, like, say you've got some civilization that has surrounded their star with a Dyson sphere, and they are consuming all of the energy that is coming off of their star. Well, they are going to be changing the wavelength of the light that's coming from that star. So when normally you would see the star, you'd be seeing it in the standard wavelengths, right? From the radio, through the visible light, infrared, ultraviolet, into the X-rays and things like that. And that would look like a normal star. And when we look out into the universe, when we look out into the Milky Way, we see all of these stars look like stars, like our sun. Like our sun would look from far away. But if you did surround a star in some kind of megastructure, then what you would get is all of that standard radiation would be blocked, and all that would be left is the heat that is now leaving this shell. And so you would see an object that would be shining very brightly in the infrared spectrum. And so then the question is, how can you block heat? And the answer is that in the end, you can't. That according to the laws of thermodynamics, and as they say in The Simpsons, right, we obey all the laws of thermodynamics in this house, You can't block heat forever. If you try to block the heat that's coming out of your Dyson sphere, you cook. You roast inside like an oven. It just gets hotter and hotter and hotter. You have to let that heat get out. Now you can imagine you've got a Dyson sphere and it's letting out heat, and then you've got like another Dyson sphere and it's letting out heat, and maybe you're attempting to shift the wavelength to something that is invisible for most people. So you shift the wavelength from bright light all the way out to radio, and then you have really long wavelengths, and maybe you can make your Dyson sphere essentially invisible. So that's one idea. The other idea is when you think about, you've got this Dyson sphere, or let's say you've got like some giant megastructure or whatever, and it's orbiting around a star, and you want to try and prevent people from knowing that you got the star. One idea that's been proposed, and this is by the Cool Worlds folks, is you shine a laser out from like David Kipping and team. You shine a laser out at a star. When a star is watching your planet pass directly in front of the star, you shine a laser at their star that masks the signature. You essentially provide the reverse of your biosignature to them to say, so that you cancel out the signature that you have. And so you would have some powerful laser, and it wouldn't be that energy intensive. And you can imagine that you are essentially, as you've identified all the potential stars that could be watching your planet pass in front of the star, and you just shoot them all, tip, 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 tap, 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 over the course of the year, and you mask the existence of your civilization from all of these other civilizations that are out there. But if they were able to observe your planet directly with the kind of technology that we're about to have, like when the extremely large telescope comes online in about 5 years, 6 years, we will have the ability to directly observe planets orbiting other stars. So you can't hide forever. You can't hide very well. And in the end, this is why one of the most productive ways, potentially, to look for alien civilizations is to look for them to have completely closed up all of the stars in their entire galaxy. You would see a whole galaxy shining in infrared, which would be just an absolute telltale signature that there is an intelligent civilization, a Type 3 civilization that has mastered their entire galaxy. Neil Yu, what is the next step towards LUVOIR and when? That's a great question. And so when we were at the American Astronomical Society back in January, man, it just feels like another lifetime ago. We got a chance to interview some of the leads of the principal investigators of all the next 4 great observatories. So HabEx, LUVOIR, oh man, and now I'm forgetting all their names, Lynx, and one other. And we got a chance to interview everybody for these great observatories. So we're going to be doing a whole episode on each one of these next great observatories, and hopefully we'll be able to answer a lot of those questions. But in general, we are waiting for the Decadal Survey, which is this time every 10 years where all of the astronomers from the United States come together, they organize, and they figure out what their to-do list is in terms of science. And then they pass that along to NASA and the other agencies, and that defines the next spacecraft that they're going to build. But we expect that what they want is the questions that is essentially they want to know the answers to these questions that will be, they will use these next great observatories to get to the bottom of this. All right, so Emil Eriksson, the president of the Mars Society, insists that SpaceX can't land on the moon without starting the Kessler Syndrome. Have you seen the new lander engines further up on the Starship? What could mitigate the risks? All right, so that is a great question. And like if you were watching the show a couple of, I guess about a month ago or so, I had Phil Metzger on, and he had done a bunch of the math about what will happen when a large enough spaceship tries to land on the moon. And what you're going to get is you're going to get all this dust get kicked up into lunar orbit. so that it acts like this shield around the moon. And then any other spacecraft that are in lunar orbit are going to get sandblasted as this material orbits. Some escapes the moon, and others will kind of rain back down at some other location. The more powerful the rocket is, the longer this material is going to be blasted out into space and floating around the moon. So it's a problem. There is no question that it is a big problem. And the solution is that you need a landing pad. Once you have a landing pad that's big enough that you have paved so that you are certain that you're not going to be kicking up any of this lunar dust, that's when a big spaceship like Starship can land on a regular basis on the moon. So you can imagine one landing on the moon every few months. But if you go to an interval that's faster than that, you're going to start kicking up a lot of material, and we're going to have a problem. Leonard Lindstrom. So Fraser, where were you last night when over 6,000 of us were watching stainless steel frost over the Starship SN4 loaded with LOX in liquid methane live on NASA spaceflight? I don't, sleeping, I think. No, wait, 9 to 12 Pacific time. I think we were playing a role-playing game yesterday at that time. I was game mastering a Star Trek role-playing game that we're playing, which we're calling Borg Pickers. But yeah, so I wasn't watching, but we report on it. And so I'm sure we'll have a story shortly. I want to see that thing fly. I mean, we're like the fact that Starship, we talked about this last week when we talked to Das, that Starship now, they've tested the cryo test. They've got one engine mounted in SN4. Maybe it's going to be SN5 is going to be the one that actually does the hop test. But we are getting closer and closer to actually seeing Starship fly. And that is just one more step coming to us being able to actually see this thing go to orbit and return from orbit. And I cannot wait. Zod of heaven, are we just too locked in to see our own tech to see that aliens won't be using anything like radio waves? So we get this question quite a bit, right? It's like, why are we so self-centered to believe that aliens are going to use our technology to communicate with us? Well, what else can you use, right? All we can use is the laws of physics as we understand them today. Right? All we understand is we can see radio waves and we can see lasers. Maybe if we have a really powerful, like a really good detector, we could sense neutrinos being sent at us from some other location. Maybe future gravitational wave observatories will allow us to detect gravitational waves as someone is trying to communicate in that way. So now we would assume that an advanced civilization would know the laws of physics and would take pity on us, poor, sad, uneducated humans, and fire a coherent laser beam at us to tell us that we're not alone. Like, just send us like a pity message. So, yeah, I mean, it doesn't hurt to try. Why not? Why not look, right? So take your radio dish, point it at a planet, point it at a star, hope to hear a signal. If you don't hear a signal, don't say that that doesn't mean that aliens are out there. It just means that we haven't seen them yet. And I can imagine if we were trying to think of a way that we could communicate with a tribe that was hidden on some island, right? And we would think of a way to communicate with them that we would suspect they would be able to see the message. We might take a boat and put and light something on fire near their island to let them know that they're not alone. We wouldn't pick up the phone and go, those dummies, they can't answer the telephone, therefore they're not worthy. So that's what I would do. William Becken, would it be possible to fuse the lunar soil so that it is not kicked up by exhaust from rockets? Yeah, I mean, the lunar regolith, with a few interesting technologies, would serve as a really good construction material. And so you would just go and take this lunar regolith, you would suck it into or scoop it up into your smelter, your concrete production facility, and then you would lay down concrete that was essentially dust-free. And remember that dust has been falling on the moon for billions of years. And so once you actually lay out a landing pad that's big enough, then you don't have to worry anymore about that dust. You're not going to have fresh dust that's going to be blowing onto your landing pad with the wind, right? Like you may have to go out and vacuum it every 10 years or so, but until then, you've solved the dust problem. So lunar regolith, we know, acts like is going to be a great construction material, and a lot of the things that we're going to be building on the moon will be just straight out of using lunar regolith. There's all kinds of good stuff in it, right? There's silicon, there's aluminum, there's titanium, there's iron, tons of oxygen, obviously, and so you'll find that magnesium, that there's no shortage of building materials on the moon. The problem is just that it is on the moon. Aaron's asks, so WFIRST is a twin of Hubble. If Hubble breaks, then WFIRST will be the replacement of Hubble? No, WFIRST is not a twin of Hubble exactly. Now, it is the same size telescope as Hubble. So the way this works was when NASA built Hubble and they launched Hubble a couple of years ago, I guess it was quite a while ago actually at this point, the National Reconnaissance Office gave NASA 2 Hubble-class telescopes that they weren't using anymore. That they just figured that the technology was obsolete. So here you go, have a free Hubble Space Telescope. And NASA took one of these telescopes. The other is still mothballed, but they took the other one and they started to turn this into WFIRST. So when you think about the Hubble Space Telescope, the Hubble Space Telescope is able to see across from the infrared spectrum, from the near-infrared spectrum, like when you see that heat signature in an infrared camera, through the visible spectrum and into the infrared spectrum. That's the capability of Hubble, and it is a very small field of view. WFIRST is more into the infrared. So it's going to be able to see through gas and dust. It's going to be able to see farther, essentially back in time, as it's able to see objects that are more redshifted away from us. But it also has an incredibly wide field of view. And I forget the exact field of view. I should learn this. But it's going to see, a much bigger swath of the universe all at the same time. So it's a very different instrument. WFIRST is more like a follow-on telescope to Spitzer, although really James Webb is a follow-on to Spitzer. So we're not going to have a real replacement for the Hubble Space Telescope until we get LUVOIR, which we're looking, 2035. So hang in there, Hubble. F0. What's going on with the asteroid that just missed the Earth recently? That happens all the time, right? There are asteroids just missing the Earth all the time. Big ones, little ones. You have to change your definition of what just missed the Earth means. So generally, astronomers will measure the distance in Earth radii, or say distances to the moon. And a lot of the times, as these asteroids come close to us, the moon is, say, 400,000 kilometers away. And one of these asteroids will come halfway between the Earth and the moon, and that's a pretty close call. Or it will be twice the distance from the Earth to the moon. So you'll have an asteroid came by at, 800,000 kilometers away, 1,000,000 kilometers away. That's very far. So this happens all the time, and there are a bunch of websites, there's a bunch of news agencies that clearly have figured out that every time they predict that there's going to be an asteroid coming close to the Earth, which is true, right? They come close to the Earth all the time, that they can get a bunch of clicks and they can get a bunch of people to come and show up on their website. And that is kind of not scientific. I wouldn't say it's super ethical. And so we debunk this all the time with Universe Today. We're like, no, asteroid, just pick the date, 2006, is not going to hit the Earth. In many cases, they're going to come. What's great about them is it's an opportunity to see an asteroid as it is coming close to the Earth, if you have a telescope. So you can like take your telescope outside. If you know exactly where to watch, you can watch a dot move through your field of view very quickly, and it's pretty cool. But astronomers keep track of a list of objects that they are worried about. They have this thing called the Torino scale, and it goes from 1 to 10 with, and I forget which one it is. One being one side of it is apocalypse, and the other side of it is maybe an asteroid in the far future is going to maybe cause a little bit of damage on a local level, and so they have a few objects that they're keeping an eye on. But apart from that, so Arjun asks, how close to Earth is close? Yeah, so the close is when, I mean, with asteroids, you can never know their exact position into the future, right? Astronomers will look at the track of an asteroid and they will chart its position months, years, decades into the future. Beyond a certain point, the uncertainty of the position of the asteroid gets to the point that it just doesn't matter anymore. You don't know where it's going to be. And so as you're able to predict it more accurately, you get this cone of future locations for where this asteroid is going to be. And if that cone, if that probability cone goes across the Earth, so the Earth is at a spot when the asteroid is at the spot, and it's a probability 10 years down the road, 20 years down the road, but it's still within the probability, that's right? That's when you say, let's do more observations on this asteroid as it gets closer and see if we can we can narrow down the uncertainty to the point that we are certain that it is no longer an issue. And at this point out, astronomers have ruled out literally every large object in the solar system, all the large objects, all the planet killers, right? All the Armageddon objects we are safe. But there's still tens of thousands of objects that are smaller that are in the 100 meters across size that still have to have their positions locked down. And there's some great new observatories that are in the works that will help us figure these out. D-Stonks333. Question, how much damage will the COVID-19 pandemic cause to space exploration budget and put everything on hold? That's a great question. And we don't know what the future is going to hold for this pandemic across every field. I mean, right now we're seeing the launch of the SpaceX Crew Dragon on May 27th, which seems like it's still going to be going on track, which is awesome, right? But NASA is taking precautions. So we actually just got the message today that our photographer is not able to attend the launch. So I think a lot of people, for precautions, for COVID reasons, NASA is not going to let journalists show up and actually cover the launch. So that sucks. We're going to have to take pictures from NASA and not have our own shots. And I'm sure a lot of the other people are going to be dealing with the same situation. And that's just from us, right? You're seeing like how much work can you do on a spacecraft if you can't work on the spacecraft? So the stuff that's already far along, it's already on the spaceship, it's already on the rocket, it's already in the fairing, maybe you can launch that. Stuff that's in the design phase where you can work on it from home, they're able to control the rovers from home, that's pretty cool. But if the stuff is in that in-between stage where you're actually trying to assemble hardware and you're trying to be in the same clean room with a bunch of other engineers, that might be difficult. So I think what we're going to see is we're going to see the stuff that's already very done. We're going to see that stuff continue on. Maybe there's going to be some delays as things are a little more complicated, but we're going to see that launch. We're going to see that completed. The stuff that is in the design stage, that's all still going to be able to move forward. But there's going to be this middle part, the stuff which should have gone into the engineering phase, that's going to have to be kicked down the road. And so whatever time is lost now, we're going to see that gap show up, the lag show up a year down the road, 2 years down the road as these various missions. But then, we see that each individual mission has its own special lag all the time. Some missions are delayed, some missions come in on time and on schedule. So we may not see any appreciable difference in terms of space exploration. From a news standpoint, I mean, there's still tons and tons of news coming out. And now a lot of observatories were shut down, but we're seeing some observatories come back online again. And the scientists have been very busy. I mean, a lot of the work they do is sitting at home with their computer crunching numbers. And so we're still seeing a ton of research coming out that we're able to report on for Universe Today. So there was like, maybe back in March, things were looking a little difficult. And now it feels like, as we're in early May, it feels like there's as much news as there ever is. So my feeling as a news editor is right now, the news is still flowing pretty fast. So Sean Marston says, hey, Fraser, wanted to let you know that my daughter Sophia got an A on her science report about Jupiter. We watched your show and you answered a question that she had about space. Thanks for what you do. Awesome. That's what this is about. Helping kids get A on their science report. Tesla Ranger. How is the curvature of space determined? Now, we've done a bunch of episodes about the curvature of space. And of course, the question, I mean, there's sort of two kinds of parts to this idea of curvature of space. One is the curvature of space-time as massive objects distort the space-time around them. And so, for example, the moon is orbiting around the Earth, not because the Earth is sucking the moon in, but because the gravity of the Earth has distorted space-time so that the moon thinks it's following a straight line, but it's actually following a curved path. It's really just following the space-time. So that's sort of one way that you measure the distortions of space-time, the curvature. But the other one is sort of this idea at the largest scales. When we say that the universe is flat, right? That what that really means is that if you go in any direction, you're not going to return to your starting point, right? If you're here on Earth, and you go in any direction, right, you return to your starting point. If you have parallel lines on Earth, they will converge, right, or they will diverge depending on where you are on the Earth. But the measurements that have been made in space is that if you have two parallel lines, they will travel together in parallel forever. And so that's what astronomers say. That's why they say that it's flat. And the way they determine that is essentially they look at the universe in the largest scales and they map out triangles of space. And they use trigonometry to calculate if there's some overall curvature to space itself. Like I said, we've done a whole video on this idea, like how do astronomers know that the universe is flat? And it's incredible. It's an incredible feat that astronomers are able to go through to be able to make these determinations. Julius Stanionis. What if the overwhelmingly large telescope would be built? Would that be like Christmas to the power of 10? Christmas birthday to the power of 10. So for people who don't know, right, the largest telescope that's in the works right now is called the Extremely Large Telescope. And I think it has like a 40 meter size. Can't believe normally I have this stuff in my head. I feel bad. The Extremely Large Telescope, very big. But as the European Southern Observatory was working on their idea for the Extremely Large Telescope, they had a bigger one planned called the Overwhelmingly Large Telescope, and it was going to be 100 meters across. And essentially, 100 meters is the largest telescope that would be possible to be here on the surface of Earth. At a certain point, the gravity of Earth would pull your telescope, warp your telescope so that you couldn't keep the optics without really super overbuilding it. And unfortunately, they decided that it was going to be too expensive because, it was going to cost like $1 billion. And they were like, no, we can't spend $1 billion. I forget the exact price, but the irony, of course, is that so much more money has been spent on things like James Webb. And yet, when you imagine the capability of a telescope like the Overwhelmingly Large Telescope, it would just be mind-bending. So, It makes me sad. And in fact, we did an episode about what if you built the overwhelmingly large telescope on the moon, just to be ridiculous. And you can kind of imagine the capability where you have no atmosphere and no gravity distorting your telescope, and you know, just this incredible view from the far side of the moon. So, Darren Clark, how confident are you that we will see boots on Mars in your lifetime? Well, you know, as I get older, right, and as my robot body doesn't show up, then, you know, we wonder what that means in my lifetime. So really, I think that we will see humans walk on Mars in the 2030s. So I know that the plan is that SpaceX is going to send the Starship to Mars in 2024, maybe 2026. Boom, you've got 100 people showing up on Mars and starting the Mars city. I am more skeptical, and I think it will take longer because it's going to be harder and there's going to be more challenges to make this work. So, but I do feel like they're going to try a bunch of attempts. They're going to work out the kinks. And at some point in the mid 2030s, we're going to see probably a Starship. If I had to sort of pick the system that I think will actually make the journey, I think it'll be a Starship. Now, it might be a Starship carrying something else, right? It's going to be a Starship carrying some NASA lander on board. And the Starship's going to do the most of the journey and then drop the lander off or whatever. But I do feel like we're going to see humans walk on Mars in the mid 2030s. So, like, if I had to pick a day, 2035. I guess, I'm not sure if that gives us a window. So, I have to pick which window it's going to be. Rami Iman says, does NASA or CSA see any opportunities in the rising interest towards space in the Middle East and Arab region for collaboration? Now, I don't know specifically what relationships NASA or Canadian or the Chinese Space Agency are having with the Middle East, but I know that the Middle East is putting a lot of emphasis. I mean, there is a plan from, is it United Arab Emirates, to create a city on Mars. And their plan is to send a lot of people to Mars to establish a base at some point, I think, you know, by the middle of this century. So there's already a ramp up of a lot of really interesting missions that are coming out of the Middle East. And I would expect, you know, as they have, I guess it all depends on oil prices. But you can definitely see, I mean, I think that for a lot of these countries that are rich in natural resources, the writing is obviously on the wall that you need to shift from being a civilization that is based on pulling dead dinosaurs out of the ground and lighting them on fire to something that is more sustainable over the long term. And of course, we see that with the oil shocks right now, how precarious that situation is. And so what's the future? The future is robotics. The future is computers. The future is renewable energy. The future is space exploration. So I think we're going to see, this is a long-term, it's the same thing we're seeing in China, that this is the high ground. And so I think we're going to really see these various organizations try to figure this out. So, E.V. Scott and Flower, do you think that Elon will die on Mars? I think he'll try. But I mean, I've talked about this quite a bit before, which is that there is a sense of wonder and accomplishment and adventure and achievement to try to go to Mars and try to live on Mars. And I mean, we are experiencing some version of that right now, where we're all trapped in our houses. And this is kind of what it's going to feel like, except you can't even go outside without having to put on your big spacesuit and get into your, you know, take an hour to get your spacesuit on and go through all of the protocols, et cetera, to be able to do that. So if this doesn't feel like fun, then you might not be cut out for for that kind of an adventure, right? And so, you don't see people trying to go and live in Antarctica. I mean, Antarctica is 1,000 times more habitable than Mars is, more habitable than the moon is. And yet we sort of have that worked out. Like, I get it, it's cold and there's no food and you're desperately trying to survive every single day. And that, I think, gets a little old after a while. So I think that for the moon, like, I don't see cities on the moon until our technology just gets so ridiculous that it's easy. I see a research center. I see a station on the moon like McMurdo at Antarctica, where people go and are supported by a tremendous amount of technology, and it's probably funded by governments, where they can go and do really interesting research on the moon, run some telescopes and things like that, right? And then I see with Mars a similar thing. Wouldn't it be amazing if there was a permanently inhabited base on Mars where you've got every 2 years another group of astronauts fly to Mars and they go to the base and they do their tour for 18 months on Mars, and they do more interesting and more complicated exploration efforts, and then they hop in their spaceship and they come home, and they will have incredible stories to tell us, and they will have learned a tremendous amount about Mars. But for the average person, if you feel that is in your heart to carve out an existence from an environment that is difficult, and I'm looking at you, Cody, then get to work now. I mean, you can experience most of it already, right? Which is like, you just go somewhere that's far away from the internet, that you're gonna have a really hard time surviving. But you still, like, by all means, drive your truck into town and resupply, and, like, just see if you dig it, right? And if you are, then maybe you are cut out to go and try and survive on Mars. And there's a bunch of people on Earth who are, and I can't wait to watch them try. And I will be cheering for their success. But it's not me, and I think for a lot of people who think it is them, it's not them. What is for us is, to have the comfort, to be able to walk outside and breathe the air. So we'll see. I think we're going to have to find that balance. And then over time, as we just get more and more capability, as the technology gets more powerful, as our ability to live in space becomes more effortless, then we will see us expanding across the solar system. But that's hundreds of years into the future, when we have that kind of effortless habitation in the solar system. And that's the difference, right? We're not there yet. We can go live in the desert, in the Southwest desert, a place that's very inhospitable, and we can do it now essentially effortlessly, right? Because we've got all kinds of incredible air conditioning technology, and we've got cars, and we've got infrastructure and roads and highways and desalination systems and all that kind of stuff that makes it so our technology allows us to do this kind of thing. And we'll need something similar, some level of similar technological advancement before we can try to live there. All right, let me continue on. Apologies. So F0, can a golf ball travel at the speed of light or turn into a black hole? So no, nothing can travel at the speed of light. Even, if it has mass, it can't travel at the speed of light. Will it turn into a black hole? No, but the answer is incredibly complicated. And we have answered it, I think, in a question show, but let's see. Bill Nash over on Twitch. Hey, Twitch. What do you see as the biggest potential positive change coming from technologies like Starlink, and will it be complete before James Webb? Yeah, I mean, Starlink is already, from what I've heard, Starlink is planning to go into a closed beta test in about 3 months. Ooh, Elon, pick me. And then an open beta in about 6 months. And so in theory, within about 6 months, we're going to be able to start signing up for Starlink, the ability to get high-speed internet from anywhere on Earth. And by the end of this year, it should be, in theory, again, pretty robust, where you will be able to sign up for the service and you'll be able to use that. So that is going to happen before James Webb launches, for sure. What is the biggest positive change? Well, I mean, here we are in in a time where our economy has been shattered and everybody has to go and move home. And for those of us who live in fairly high density areas, like I live in a place where I have incredible internet, wonderful internet, so fast. And I don't have to pay very much for it, right? I pay whatever. I pay $100 a month for 600 megabits down. But what about a person who lives on a farm? When I forget the number, something like a quarter of Canadians just have no access to high-speed internet at all, right? And they are farmers, and there's various businesses and even just small communities, right? Like, why do you have to be a part of the modern society, but you also have to move into the big city? Why can't we distribute that load across the country? And a big part of it is that in the past, humans have always needed to concentrate in these big cities because that's where the jobs were, that's where the infrastructure was, that's where everything is. But now we don't have to, right? And so, yeah, I think if Starlink existed a year ago, then a ton of people who are now like trapped at home and they have no way to make money at all will suddenly would have had a way to be able to access the internet, high-speed internet, and be able to do work. Now the question, of course, is it has to be cheap, it has to be affordable, and Musk has said that it's going to be. We're going to wait for the rubber to hit the road on this one, right? What's it going to do to astronomy? It's going to make astronomy worse. Yeah. Now the latest launch, they've launched one version of the satellite where they're trying to have there's like a visor that will block the sunlight from glinting off the satellite, and maybe that's going to drop it by a couple of magnitudes, which would be incredible. Match that with the darker painting that they do on them, and maybe some other technologies that will make these things, go from being very bright to being moderately, a moderate nuisance, which would be wonderful. But again, we have to weigh this, right? Affordable access for half of humanity to access the internet, to a degradation of our ability to do astronomy. Weigh them. So the ability for half of humanity to access the internet has to take a higher priority than a degradation of astronomy, right? Unfortunately. So as an astronomer, as an amateur astronomer who literally has to yank trails of satellites out of my pictures, it sucks. I hate it. Makes me mad, but I get it. I get the bigger picture. And just imagine, we want that. We want that future, where there's like great big space stations and starships flying. Those things are going to be reflective. So, we've just, it's only begun. We are going to lose the skies one way or the other. Forward synthesis. How long until we find and confirm the existence of an exomoon around an exoplanet? There are those who believe that an exomoon has already been discovered. Of course, this is a moon orbiting a planet, orbiting another star. And when you think about how difficult it is already to be able to see the planet, it's even more complicated to be able to see the moon. And so the kind of situation that you're going to need is you're going to need like a very small star, like a red dwarf star, a very large planet, and then the moon positioned perfectly as it's going around, where the star or the planet blocks some of the light from the star, and the position of the moon also affects more or less the light of the star. And it's kind of inevitable at this point that astronomers will detect one of these exomoons. It's going to take more observations, and there are some just absolutely incredible. I mean, the Cheops instrument right now, the one by the European Space Agency, which has already begun its observations, its job is to characterize exoplanets using the transit method. And so it's going to be watching thousands of exoplanets and try to just give astronomers a lot more information. So I wouldn't be surprised if Cheops is the telescope that actually confirms the existence of a moon around another planet, which is such a great idea, right? That brings in this whole idea of habitable moon. So even if the planet is uninhabitable, suddenly the moon orbiting the planet could be habitable. And in fact, some people think that it actually would be more habitable, it'd be a better place, because you would get quite significant tides flowing back and forth on the planet. Or the moon orbiting the planet. I know it gets very complicated. So stay tuned. I'm excited about this as a potential into the future. Isn't it cool that we are here in this moment where we don't know everything about this yet? From when I started this job, we only knew of a handful. Like, I think we knew our first planet was like in 1995. And so I started this job like 4 years after. And so we knew like less than 20 planets, I think, when I started this job. Now we know more than 4,000. We will be knowing hundreds of thousands, millions of planets within the next couple of decades. And we will find exomoons, and we will find just every possible combination. And we get to watch this all unfold in real time, which is incredible. William Beckham, have a drink, Fraser. Yeah, I forgot to bring my water. So I got 10 more minutes. I can make it. A little parched. So, there you go. People are talking about, oh, okay. Nicholas Alt is saying, I saw 4 satellites in the same trajectory go over in about 5 minutes a week ago. Was that probably a recent Starlink launch? Maybe. The Starlinks, actually, when they're recent, you see them, there are about like a train. Some of them are a little brighter, others are less bright. And so you can see, so if you saw 4, if you looked at them with a pair of binoculars, you would probably see the rest of them. And so you see this train of 60 satellites all boop, 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 boop. It's very cool to see. I mean, yeah, absolutely. It means that your skies are getting worse, but it's cool to see them. Aaron's, do you believe that phrase, we're born too early or too late for space travel? It depends on what you want, right? I think that you will always be born too early for the future. When I think about the kind of technology that we have today, and I think about how, say, my mother and my father were both very technologically advanced in their, my mom used computers, but she passed away really before the smartphone era, being able to appreciate really the power of the internet to this level. My dad, he was a child of the Apollo era. He watched them land on the moon. But, even now, as I'm 48, thinking about what comes in the 2035s, we wait for those humans to walk on Mars. What's going to happen in 100 years, in 1,000 years? People always ask, if you could travel into the past or into the future. My answer is always into the future. Like, I don't even have to think about it. Do you want to travel into the past or the future? Future, me. I want to go into the future. I want to see what the future looks like. Because in general, also the future is better. I know people try to fearmonger and scare you, but the reality is that we have less poverty, less death, less war, less, I would have said less pandemic, but, every now and then we have blips. But the world gets better and better year after year after year. And I can't wait to see what the future of the world is going to look like. And I hope I can be around for it as long as possible. Bill Nash, on Twitch asks, between getting to Mars and Starlink, what kind of infrastructure is proposed to beef up communications to Mars, such as would be needed to keep colonists entertained, educated, and not eating each other? Has Martian Disney Plus been designed yet? Yeah, so I mean, right now, communication with Mars is actually very difficult. The spacecraft have their transmitters, and you have these 90-meter telescopes here on Earth that are able to receive the signals from them, and they're, like that's what communication with Mars looks like, is a 90-meter telescope. People always say, like, we can communicate with space, you can communicate with the Voyagers, and yet I can't receive a phone on my cell phone. Well, if you're willing to carry around a 90-meter antenna, then you would be able to receive phone calls on your cell phone. So you would need really big dishes on both Earth and Mars. And when you think about the times when Mars goes onto the other side of the sun, you would need some kind of transmitter that would be able to transmit data, or it would have to bounce off the asteroid belt or something, or go to Venus and then go to Mars. So there's going to be a lot of challenges to being able to communicate back and forth. Of course, there is the time delay. If you're going to play, you're going to have ping times of 20 minutes to 40 minutes while you try to play a game with your friends from between Mars and Earth, which, you won't be able to be a competitive gamer at those rates. So it's going to be tough. You're going to see, like, data is going to be sent back and forth in terms of archives. So all of YouTube will be transmitted to Mars once a day. And so you'll get yesterday's YouTube. So it'll feel a bit like you're reading newspapers or watching old television shows again, because the delays. So it's interesting to think about what kind of infrastructure it's going to take. But you will need big dishes that will be able to make these transmissions. Arjone, do you think the century will be more about advances in technology, medicine, or engineering? All of the above. I think the biggest technology advance that we are still experiencing, the one that is going to leverage everything, is our ability to collaborate via the internet. That is like a multiplier across everything that we do. And you can just see, for example, right now, as the scientists of the entire planet, like, I wonder how many scientists right now are working on coming up with a solution to COVID-19. 100,000, right? They are publishing their papers. They're being published completely open onto various servers. They are communicating back and forth, and they are collaborating at a planetary scale. So yeah, our interconnected civilization caused this problem, and yet also our ability to communicate is going to get us out the other side. And that just unlocks everything. Our ability to learn from each other, our ability to, and so, like, every method that slows down the data, that doesn't free the data, as someone might say, is really enraging. It's really frustrating that whoever wants to hold the data back, that wants to try to stop it from being able to be communicated back and forth, to let people collaborate and do research and share their findings, they're just getting in the way of progress. Horizon Brave, do you think the Starlink could be used as a relay between the moon or Mars? I mean, in theory, but I mean, the Starlink antenna are going to be facing down, and so they're really not going to be that useful to be able to communicate up to the moon. You're going to want more. I mean, the handy thing about the moon is that it's always showing the same face to the Earth, and so if there's like a place you want to communicate on the moon, you just have to take your dishes on Earth and point them at this spot on the moon. As the Earth turns, you point your dish, and with 3 dishes at different spots on the Earth, you can be in constant communication with the moon. And people talked about, can we use the Starlinks for other purposes? And the reality is that it doesn't make sense. Their purpose is to communicate, to allow us to have internet communications. If you want to be able to communicate with other if you want to use them for space telescopes and things like that, you want other solutions. All right. we have reached the end of our hour. Boy, the time goes so fast. Didn't you have a play button? I do have a play button. It's right there. You can't see it, but it's right there. So thank you everyone for watching. Thanks everyone for moderating. Thanks everybody on Twitch as well as YouTube. I really appreciate it, and this is so much fun. I would love to figure out a way to both have a guest, but also be able to do these live streams with you because it's such a fun format. But stay tuned. More content coming your way. I've got Moya McTeer coming next week. She's great, one of our co-hosts on the Weekly Space Hangout, but also is one of the planetary researchers working at the Cool Labs. So you can learn more about her search for exoplanets, and we'll be talking with her next week this time. All right, thanks everybody, and we will see all of you next week.